Hello students, in our previous video we learnt about resistance and its measurement through Ohm's law. In this video we will explore resistance and various factors affecting it. Let's do an activity to explore what is a resistance. Make a circuit having a battery, a switch, an ammeter, a bulb which also includes a rubber spatula. Do you think the bulb will glow? No, the bulb doesn't glow. Let's replace the spatula with a silver spoon and see if the bulb glows now. Yes, it does. Why did the bulb glow the second time? And why didn't it earlier? It is because that the rubber spatula is a poor conductor of electricity, but the silver spoon is a good conductor of electricity. Good conductors have lower resistance and allow the current to pass through the circuit. Comparatively, poor conductors have more resistance and do not allow the current to pass through the circuit. So now, can you explain what resistance is? Yes, resistance is the property of a material that resists the flow of charges through it. Now, let's replace the silver spoon with some other materials like copper wire and aluminium wire. In this activity, we observe that the current in ammeter is different for different components. Why does it differ? This is because certain components offer an easy path for the flow of electric current, while the others resist the flow. We know that motion of electrons in an electric circuit constitutes an electric current. The electrons, however, are not completely free to move within a conductor. They are restrained by the attractions of the atoms among which they move. This obstruction is known as resistance. Also, resistance is caused in a conductor by the free electrons when they collide with each other, or with ions in the conductor and atoms that oppose their free movement. Thus, we can say that the motion of electrons through a conductor is retarded by its resistance. According to the resistance offered, we can classify the materials as good conductor, resistor, poor conductor, and insulator. A material of a given size that offers a low resistance is a good conductor, for example, copper. A material of identical size having appreciable resistance is called a resistor, for example, carbon. A material of identical size that offers a high resistance is a poor conductor, for example, mica. A material of the same size that offers very high resistance is insulator, for example, rubber. Now, let us see the factors that affect the resistance of a conductor. For this, let us perform another activity. Connect the electric circuit consisting of a cell, an ammeter, a nichrome wire of length L, and a key. Now, we plug the key and note the current in the ammeter. Then, we replace the first nichrome wire by another nichrome wire of same thickness, but twice the length, that is 2L. Then we again note the ammeter reading. We observe that the ammeter reading decreases to 1/2. That is, current decreases when the length of the wire is doubled. Now we replace this wire by a thicker nichrome wire of the same length L. A thicker wire has a larger cross-sectional area. Then we again note down the current through the circuit for thicker nichrome wire. We observe that the ammeter reading increases, that is, current increases, when we use a thicker wire of the same material of the same length in the circuit. Now, instead of taking a nichrome wire, we connect a copper wire of the same length and same cross-sectional area as that of the first nichrome wire in the circuit. For this, we note the value of the current. We observe change in ammeter reading. That is, change in current is observed when we use a wire of different material of the same length and the same area of cross section. For this, we note the value of current. We observe change in ammeter, that is, change in current reading is observed when we use a wire of different material of the same length and the same area of cross section. Students, we notice that there is a difference in the current in all the cases. Why does this difference in current occur? Does the current depend on the length of the conductor? Does the current depend on the area of cross section of the wire used? Yes, students, recall that current depends on resistance, which in turn depends on factors like length, area, etc. So we can say that there are three factors that affect the resistance of a conductor. These are the material of the conductor, the length of the conductor, the thickness of the conductor, that is cross-sectional area. Now let us see relationship between all these factors. When we apply Ohm's law to our observations from the activity, we see that the resistance R is directly proportional to the length L of the conductor or wire. In other words, we can say that the longer the wire is, the greater the resistance, or R is directly proportional to L. In addition, resistance R is inversely proportional to the thickness or cross-section area A of the wire. In other words, we can say that the thicker the wire, the lesser the resistance is, or R is inversely proportional to area. When we combine both the equation, we get R is directly proportional to L and inversely proportional to A. To remove sign of proportionality and convert it to an equation, we add constant of proportionality. Here it is rho. So equation is R is equal to rho into L upon A. Here rho is called the electrical resistivity of the material of the conductor. The SI unit of resistivity is ohm meter. It is a characteristic property of the material. We will see resistivity in detail in our next video. So students, in this video, we learned that resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms and symbolized by the Greek letter omega. We also learnt about the factors affecting the resistance of a conductor, along with the introduction of resistivity. We learned how to calculate the resistance of a circuit. In the next video, we will learn about resistivity in detail.